Good evening, good afternoon, good morning, good night, whichever time of the day you might be watching this video. This is Mr. Molikash, and this is our week 15 video for Math 172 with Johnston Community College. I hope you've been getting a lot out of the videos that I've been giving you so far. Last week we were talking about ellipses, and in our next sequence of videos with conic sections, now we're going to be talking about hyperbolas. If you have a question about what you see here, shoot me an email, or you can, if you're one of my students, you can use the discussion board online, and that way everybody in the class can see your question. All right, so what is a hyperbola? If you remember previous week's video, hyperbola is what happens when you have a cone, but you cut through the cone in such a way that you can cut through two cones at once, right? Something like this. So if you're slicing through with a plane through this cone and this one, then, you know, for example, you get a line that kind of looks like this, right? Then what results in this is that you get a curve like that, and you get another one kind of like this, okay? So these two curves together make a hyperbola, okay? So the general equation of a hyperbola, there's two different kinds. And so just kind of reviewing from ellipses, remember you have x minus h squared over a squared plus y minus k squared over b squared equals 1. If the a is bigger, it's an ellipse that looks like this, right? So what happens is if you change this plus to a minus sign, okay, it does not matter if a is bigger than b. But if the x comes first and you're subtracting y, then your hyperbola is going to go outward like this. Its major axis, or we'll call this the transverse axis if you're reading in the textbook, that is horizontal, and so x is of course horizontal. So it's kind of oriented along the x-axis, and the foci are inside these two curves. Okay, we'll talk more about foci in a moment, but if we have the y part first, excuse me, if we have the y part first and then the x part, like this, then what happens is there's a top and bottom, okay, and the foci are up here, right? So the major axis or the transverse axis, these are the vertices, and this is the center. So in all of these, we'll kind of look at this first one first. In all of these, there's different parts of this that we need to talk about before we go through an example. So the center, of course, is HK. And if the hyperbola is oriented like this, then the A distance is the distance from the center to the vertex. That's A. There is a distance from the center to the focus. That length is C. Now you may be wondering where B is, like why did I skip over B, right? Well, the B, remember in the ellipse, is the part that you go up and down from, well, the smaller one's the one you go up and down. So assuming that A is bigger than B, you would go up and down B units, right? So, you know, your ellipse kind of would fit between these two vertices. But what happens with B, okay, is if you go up and down B units, and again, we're assuming that A is bigger than B, but it doesn't matter. You can go up and down as far as you want. But there's kind of like a vertical length and a horizontal length. And if you go up B and over A, then you have these lines called asymptotes. Okay, so the slope of each asymptote is B over A, or the opposite of that. So that's where the B comes in with this graph, right? The slope of this one is the opposite of B over A. And both of these go through HK, go through the center, okay? All right, now one more thing you'll need to know is that to find the distance c here, which I alluded to earlier in the video, you use the Pythagorean theorem, a squared plus b squared equals c squared. So oddly enough, if this length is a from here to here and this length is b, this length is the same thing as it is from the center to the focus. So now c is the longest length, and then a and b are the legs. You might want to contrast that with what you learned about last week with ellipses. Okay. Now, if the hyperbola is oriented vertically, like I was talking about earlier, if the y comes first and then the x, then you still go left and right a units, you still go up and down b units to find your asymptotes, but the vertices would be at the ends of the b length, right? These would be the vertices, and you'd be drawing the hyperbola up and down, again oriented vertically with a vertical transverse axis as opposed to a horizontal one. So just kind of keep that in mind when you go through that. Okay, let's look at an example of just a specific equation. So let's say that we have x minus 2 squared over 9 minus y minus 3 squared over 16 equals 1. And let's just ask a few questions about this. So the first thing we want to do is find the center. Hopefully you know what that is. We want to find the vertices. We want to find the foci, and there are 2 of them. And we want to find the 2 asymptotes. Okay. The center is pretty easy. That's just 2, 3. And don't get this confused with -2 and -3. It's already x minus h and y minus k. So it's this in the equation, it's the opposite of h and the opposite of k. All right. Now up here in the corner, I'm going to note some lengths, right? A squared is 9 and b squared is 16. And this hyperbola is one that's going to go left and right. And the reason for that is because the x is first. We're doing x squared minus y squared as opposed to the other way around. All right, well, if a squared is 9, and that makes a 3, and we're going to go left and right 3 units from the center. So if you take your ordered pair 2, 3, and you go to the right 3, then that's 5, 3. And then the other ordered pair would be 2 minus 3, and then the same y coordinate. So this would be -1, 3. Those are the 2 vertices. All right, now with the foci, remember the equation c squared equals a squared plus b squared. So if we solve that for c, we get plus or minus 5. I'll just put 5 for simplicity, but just kind of keep in mind we could go left, right, 5 units from the center. So the foci are at -3. Sometimes my mouth moves faster than my brain can think. Sometimes. Anyway, 2 plus 5 is 7. So those are the 2 foci. Remember the asymptotes, the slopes are b over a. b is 4 and a is 3. So the slopes are plus or minus 4/3. And they both asymptotes go through this center point. So one asymptote, you do like point slope form, that would work. You could do y minus y1 equals the slope times x minus x1, and just leave it at that. But the slopes are both plus and minus. So there's 2 different asymptotes. Again, one goes up and to the right, up 4, right 3. The other one goes up 4 and left 3. So one's a negative slope, one's a positive slope, and those are your 2 asymptotes. Okay? So that's just a real quick example of how to find these 4 things: center, vertices, foci, and asymptotes. And if you go graphing all this, I'll do this real quick on the back here. So our center was 2, 3, right? Our vertices were 3 units left and right of the center. Our foci were 5 units left and right of the center. And then our vertices, our asymptotes were up 4, right 3. So there's 1 asymptote. And I'm dotting this because it's just kind of a guideline. It's not actually part of the graph. So if I went up 4 and left 3, that would be the opposite slope. Okay. And asymptotes are there because the hyperbola gets really close to the asymptotes as we approach the right side, the end of the x-axis. And then same deal here. If we approach the other end of the x-axis, then these get really, really close together. Okay. All right, so there's everything. There's your center, your vertices, your foci, and your asymptotes on the graph. All right. So that's kind of, really quickly how to find the information that you needed to find here. And I'm sorry, part of it got erased because I flipped this board over, but just kind of rewinding the video if you need to see all that again. All right. So let's say we kind of have some information. And we need to write the equation of a hyperbola. Okay, so let's say that we have the foci are, let's say the foci are 1, 7, and 1, 2. And that might not work out too well. Let's try that. -3. There we go. All right, now I've got it right. So let's say the foci are 1, 7, and 1, -3. And the vertices are 1, 5, and 1, -1. And we want the equation of the hyperbola. Okay, so what we might want to do to start with is like put all this stuff on some graph paper, right? So let's kind of do that to start with. We'll put our foci on there first. So here's 1, 7, and then 1, -3. So this is a focus. We'll say this is F1 and this is F2. So that means immediately that we're going to be going up and down with our hyperbola, right? All right, and the vertices were 1, 5, and 1, -1. So that's a vertex, and this is a vertex. Okay. So the center then, if there's 6 units here, 1, 2, 3, 4, 5, 6, the center must be right there, halfway between the vertices and also halfway between the foci. So right away, we can tell that this distance is 3 units, and this distance is B. B is 3, right? That's the distance you go up and down from the center. And then the focal distance, the C distance, is 5. Okay? So we should be able to figure out the A from this information, and once we know the B and the A, we know the asymptotes, we can graph this thing, and also with A, B, and C, or with just A and B in the center, we can find the equation. Okay, so right now, right there, the center point is 1, 2. So that's our HK, 1, 2. All right, and then also we know C squared equals A squared plus B squared. So C squared being, C being 5, C squared is 25. A we don't know yet. B squared is 9. And so if you subtract 9 from both sides and take the square root, you get A to be plus or minus 4. All right, so that what that means is the asymptotes are going to go up 3, right 4. That's one asymptote. And the other one's going to go up 3 and right left 4. Okay, so we would go left and right 4 units from the center to be drawing our asymptotes. But all we need is this, right? We need the A squared and we need the H and K to write the equation down. So what we're going to do now is we're going to remember from earlier in the video that since this hyperbola is going up and down, we're going to start with y minus k squared over b squared and then subtract x minus h squared over a squared. And we know our h and k from the graphing part. So remember k was 2, right? And h was 1. and a squared, due to our work with the Pythagorean theorem, was 16, and b squared was 9, and we're done. This is the equation of the hyperbola. And if you want to check your answer, let me kind of encourage you to use the Desmos graphing calculator. So let me list that real quick. It's desmos.com/calculator. That's the one that I was showing in last week's video, and you can just type this straight up in that calculator exactly as it appears. You'll have to use arrow keys, to get your exponents and fractions and stuff done, but you can just type it straight up like this, the whole thing equals 1, and then see if the graph really does have those vertices. The center really is 1, 2. It's going up and down, and has the focal points inside those vertices, like I showed you. Okay, so that's it for this week. Hope you are having a wonderful week. Don't forget, send me an email or use the discussion board.